Hi, and welcome to our next lesson. Today we are going to be looking at Z-scores. Now what Z-scores are is basically a way that we can standardize results from raw data. So what that means is we're going to have some sort of raw score and we want to find out how far is that score from the mean. Right, so it could be that it is 1 standard deviation from the mean, or it could be 3 standard deviations from the mean. That's going to be our Z-score. Not the actual score we got, but how far that score is in terms of standard deviations from our mean. So we could have a positive Z-score, like let's say 2, which means that our raw score is 2 standard deviations above the mean. Likewise, we could have a negative score. So if we had a Z-score of -1, that means that the raw score is 1 standard deviation below whatever the mean was. Obviously, if we score a raw score is exactly the same as the mean, we're going to have a Z-score of 0. All right, so our Z-score is just saying how far is that raw score from the mean. As I said before, it's also known as a standardized score. This way we can easily compare stuff. So if let's say we had a student doing extension 1 and we had a student doing standard 1, obviously the standard 1 course is going to be a lot easier than the extension 1 course. What we can do though is we can compare those two students by seeing how they performed in terms of the mean. So if I've got a student who in extension 1 got a Z-score of -2, and then I've got a student in standard who has a score of +2, well, the standard student is 2 standard deviations above the class mean, whereas the extension student is 2 standard deviations below the mean. So looking at them just at that level, well, the extension student isn't doing as well in the class as that particular standard student. That's not to say that if we put the extension student in standard, they wouldn't do well. It's just saying how they are performing in terms of the rest of the class. So how do we work this out mathematically? So our Z-score is always going to be whatever our raw score is. We then take the mean away from that, and then we're going to divide it by the standard deviation. Now I've got there x minus x bar, which is our raw score minus the mean, divided by sigma x. Now sigma x is our standard deviation for the population. Depending on what you are given, it could be a sigma or it could be an S. Sigma is our population standard deviation, S is our sample standard deviation. Let's look at an example. So we've got a normal distribution, we've got a mean of 62 and a standard deviation of 11. So we want to find what's the Z-score if we have a raw score of 84. All right, so we want to use our formula that we just saw. So it's our raw score minus the mean, all divided by our standard deviation. So our raw score was 84, our mean is 62, and our standard deviation is 11. So I'm just going to substitute those straight in. 84 minus 62, all divided by 11, is going to give me a Z-score of 2. So that's 2 standard deviations. That's what that represents, our Z-score. So interpreting that, that means that the person who got a raw score of 84, they're 2 standard deviations above the mean. Now remember when we looked at our 68, 95, 99.7 rule, if they're 2 standard deviations above the mean, those 2 standard deviations would be 95% of all the results. So we take away those 95 results, we're only left with 5%. Half are going to be below 2 standard deviations, half are going to be above 2 standard deviations. That means that 84% is going to be in the top 2.5% of that particular class. At this stage, when it's asking you to interpret the results, when you come back with a Z-score of 2, that's just saying it's 2 standard deviations above the mean. Example 2. So we've got the heights of a group of young women which have been measured to have a mean of x bar 160 centimeters, and they've got a standard deviation of S, which is 8 centimeters. So we want to determine the Z-scores of a woman who is 172 centimeters. The fact that the standard deviation is an S instead of a sigma means nothing at this point in time. All right, so we want to use our formula. So this is our raw score minus the mean divided by standard deviation, in this instance S. So our raw score was 172, X bar is 160, and S is 8. So substituting those in, using a calculator, we should hopefully get out that we've got a Z score of 1.5. So what that means is this person who's 172 centimeters tall, she's 1.5 standard deviations above the mean. All right? Our Z score is just telling us how far above or below the mean a particular score is. So then part B, we've got a different female who's 150 centimeters. So again, we want to use our raw score is 150, our X bar is 160, and our standard deviation is 8. So if we look just at our mean of 160 and we've got someone who's 150, they're shorter than that mean. So we should expect to get a negative Z score. But we'll substitute those values in, and then when we do in the calculator that little bit of arithmetic, we get negative 1.25. So a Z score of negative 1.25 is just telling us that this female of 150 centimeters is 1.25 standard deviations below the mean. Example C, 160 centimeters. So again, same formula, nothing different there is changing. We've got 160 minus 160 over 8. Well, it doesn't matter what we divide it by, we're going to have 0 on the top. So our overall Z score is 0. So remember, if we get a Z score of 0, it means that the person has the mean. So her height of 160 centimeters is the mean height for this particular group of women. Right? All our Z score is telling us is how far our scores are from the mean. Right? That's the whole thing we need to get out of this particular lesson. Z scores, how far away is that score from the mean? And that is it. All right, so relatively short video today. The whole idea is we want to be able to calculate a Z score, and what a Z score actually is, we need to understand that. All right, it's just how far a raw score is from the mean. Textbook, you don't have to do every single question. Questions 7 and 8, that just asks you questions like what Z score would we get if we were 2 standard deviations above the mean? Well, you'd get a Z score of 2. What would be our Z score if we were 3 standard deviations below the mean? Well, that would be -3. Those are simple questions. So you don't have to worry about those. Question 9 wanted you to do some stuff in Excel. I'm not saying don't do it. You can if you want to. I'm just not expecting it. What I would really like though is if you could do questions 1 through 6 and then 10 and 11. As always, if you've got any questions or you're not sure about something, you can either email me or send me a message through Google Classroom. But otherwise, yes, that's it for today. I hope you're all doing well, and I look forward to seeing you all again soon.